All right, this is question 6 of WeBWorK 2.5. And this question, we're tackling a little bit different problems, but utilizing the same techniques. We're finding work, but this time done in lifting a bucket. So we're given a lot of information here. The bucket is 5 pounds, and it's attached to a rope, lifted from the ground into the air by pulling 23 feet of rope at a constant speed. And we know that the rope weighs 1 pound per feet. How much work is in lifting the bucket and the rope? So now first, I'm going to find work done in lifting the bucket without the rope. So we're not looking at the rope weight. We're just looking at in the air by 23 feet and how much it weighs. So 23 feet times 5, that is all. Multiply those together, and that gives you 115 feet per pound. And that is the answer to question, or not question, but part 1 of 6. That would be a short question. Part 2, now we're wanting to assume the force required to lift the rope is equal to its weight. Find the force function f of x that acts on the rope when the bucket is at height of x. So what we want here is to find any height at an arbitrary x. So it's going to be different. So we have our height that we know, 23. For any x would be minus x. Now we need to consider the rope weight, so put that in parentheses and multiply that by 1, which is just equivalent to 23 minus x. So this gives us the height at any arbitrary x. And this is our answer to part 2. Now we have our f(x), we can plug that in to our integral, which is w rope equal to, the bounds is from 0 to 23, because that's how high it goes. And then we have 23 minus x dx, and that is our answer to part 3. Now we just need to integrate this. So let's rewrite it. Here, 0 to 23, 23 minus x dx. But using power rule, we know it's 23x minus x squared over 2. 0 to 23, we're just going to have to plug in 23. 23 times 23, so 23 squared, which is 23 also squared over 2. All of that minus 0, which is equal to 23 squared is 529 minus 529 over 2, which is just 1058 over 2 minus 529 over 2, which is just 529 over 2. And that is our answer to question 6, I believe, part 4.